Hello students, welcome to the heat transfer module 4. We are discussing a topic on radiations. Okay, we have know already that it is one of the mode of heat transfer other than conduction and convection. So radiation process and properties. So the thermal radiation requires no matter and applications are industrial heating, cooling and drying process, energy conservation methods, fossil fuel combustion and solar radiations. Okay, so example for the radiation you will experience is that, so whenever the bulb, for example incandescent bulb or a lamp, even it is gives light as well as heat. So when you stand near to that, you feel that some heat experience, you receiving some heat. So that is also one kind of radiation. So even the sun is emitted uh, radiation to the earth. It is also one of the radiation phenomena. So the objective of this radiation is which thermal radiation is generated specific and nature of the radiation and manner in which radiation is interact with the matter. Okay. So here you can see the person is having a 30 degree centigrade body temperature and air is at 5 degree centigrade and fire is 900 degree centigrade. When the fire is having more temperature, due to the electromagnetic waves, the body is receives the heat. So heat is already, it transfers from high to low. So the body, even though if he not touch, also he feels the receives the heat. So the radiation can occur between the two bodies even when they are separated by the medium colder than the both. And solar radiation reaches the earth after the passing through the cold air layers after the high altitudes. Okay. So fundamental concept: the saturation temperature of the body, surface temperature of the body is greater than uh, surface temperature. Okay, and there is no conduction or convection. Still, solid will cool, and solid gets cooled and emission of thermal radiation from the surface of the solid. So here the vacuum, in the figure you can see the surface of the body temperature due to the surface radiation emission. Again the surroundings are covered by vacuum, this temperature surrounded by that, so radiation from the surrounding. So this due to this temperature difference, it receives the heat transfer. And one thing you should remember that in radiation, temperature is always absolute. We consider for the absolute temperature, that is the T plus 273, means whatever the temperature will be there, we have to add 273 and consider for the absolute temperature, and it's the power of to the 4. Okay, according to Newton's the Stephen Boltzmann law, you know that the Q is equal to sigma A into delta T to the power of 4. So where sigma is nothing but Stephen Boltzmann's constant. And fundamental concept of this, that is propagation of electromagnetic wave. And the scientists, the Maxwell accelerated these charges and electric current gives rise to the electric and magnetic fields. These moving fields are called electromagnetic waves or radiations. Electromagnetic radiations. So this energy emitted by this matter result of the changes in the electronic configuration of the atoms or molecules. And here there are different range of wavelengths. The depends upon the color, the wavelength band will be there. So violet 0.4 to 0.44 micrometer, and yellow is 0.54 to 0.6 micrometer, like that. So depend upon the color, the wavelength band will be changing. So next, solar radiation. The electromagnetic radiation is emitted by the sun in the range of 0.3 to 3 micrometer. Okay, some portion in visible range and other portion is in ultraviolet or infrared range. And radiation intensity, it is emitted by the surface propagates in all directions and incidents on the surface may come from the different directions, and responses of the surface to the radiation depends upon the direction. Okay. And the direction effects gives an we call it as radiation intensity. So suppose in the certain area the radiation is emitted is more, okay, and per meter square area we call it as the radiation intensity. That depends upon the directional effects. That concept we call it as radiation intensity. And these are all emission from the real surfaces. Real surfaces means in practical, so there are variety of bodies and ceramics, carbon, glass, rock, soil, building material. So how we are using the material, depending upon the material also, it receives the heat. So you must understand that the black body is one of the ideal body. So it is the more having absorptivity. Okay, so let us discuss what is Kirchhoff's law. So again, it consider a large or isothermal enclosure of surface temperature within which several small bodies are confirmed. So here this equation gives G is equal to EB of Ts. So what is EB? That is emissive power of the black body, and Ts is the surface temperature. So we have considered the different area of the body A1, A2 and A3, and whatever the energy emitted by each body we call it as E1, E2, E3 like that within the surface temperature of the body. So again the epsilon 1 divided by A1 is equal to epsilon 2 divided by A2, epsilon 3 divided by A3 and so on. The value is equals to 1, and for any surface enclosed area the epsilon is equal to A. So total hemispherical emissivity is equal to total hemispherical absorptivity. Here A is nothing but absorptivity. Absorptivity is considered for this hemispherical geometry. Okay, so the restrictive condition of this inherent in this derivation is what we have to derive it. The surface irradiation has been assumed to correspond to the emission from the black body at some temperature as the surfaces. You can see this equation epsilon lambda of T is equal to A lambda of T. It is valid only when G is independent of the direction, that is intensity of the radiation. So here the form of the Kirchhoff's law state that involves no restriction is the spectral direction form. That is, we can write epsilon lambda comma T of theta of T is equal to A lambda comma theta of T. So this is the Kirchhoff's law. So it is very tempting to use Kirchhoff's law in radiation analysis, and the relation is epsilon is equal to A together with rho is equal to 1 minus A. It enables us to determine all the three properties of a opaque surface from the knowledge of only one property. Although this epsilon is equal to A gives acceptable result in almost cases, in practice we have to consider for the difference between the surface and the source. Before that, the black body is always absorptivity 1. So there are three properties. One is absorptivity and transmittivity. Okay, so when the material is strikes with part of radiation is reflected, the part is absorbed and part is transmitted. Okay, so reflectivity, transmittivity and absorptivity, the sum of all these, the value is 1. Okay, so for the black body absorptivity always 1. So other than black body is always less than 1. That you should remember. So next one is the view factor concept. There are different surfaces at a certain distance, and here are the some factors comparing between the surface 1 to 1 and 1 to 2 and 2 to 1 and 2 to 2. These are the possibilities. So if you are consider the surface of n square, you will get 4 v factors. So that can be done by directly by using this formula, that is n into n minus 1 by 2 is equal to 1. And in this case the surface factor of 1 to 2 is 1, and f2 to 1 is equal to a1 by a2 into f1 to a1 by a2, and f1 1 to 2 is equal to a1 by a2. So both f2 to 1 and f1 to 2, both surface factor view factors are same, and for surface view factor of 1 1 plus 1 2 is equal to 1. Hence we consider this for the 1 1 is 0, so hence f1 to 2 is 1. So f2 1 plus f2 2 is equal to 1, so we have to consider for this view factor as 1 and find out f2 2. So 1 minus a1 by a2, because f2 to 1 is a1 by a2. So here the view factor of the f2 2 is 1 minus a1 by a2. So these view factors of different surface and different combination they have given in the chart in the heat transfer data handbook. So we have to use, and wherever it is required for the for formula or this v factor relations, you have to use and solve the problem. So I hope you understand this theoretical concept. So already we have discussed some of the problems in this video, coming videos. Okay, thanks for watching.